Alright, this is the assignment in this lecture today. So you are given a square, this is in green, the line are not straight, that's fine. And we have 4 charges at the summit or the vertex of this rectangle. The size the sides are given 4 centimeters, 4, this is Pythagorean theorem, 5 centimeters, 4 and 3. And the question is, what is the work required to assemble this charge to this configuration? Or what is the electric potential energy stored in this configuration? Same thing. So now here we are going to build step by step potential then energy, potential dash energy. Once you find the energy, once you find the potential at the given point, the potential time the charge at that point is the energy we are talking about, and you add them step by step like we did in the lecture. Here we have 4 charges, so I'm going to start from A, ignore everything. The only charge I'm interested in is 4 microcoulomb. This 4 will create potential at point B, so I'm going to call it VB. So the potential due to the charge 4 micro here. And so VB is the constant charge source of the voltage, which is 4 micro, and divided by the distance, which is 3 centimeters. That is 12 10 to the 5th power volt. Okay, now that I know the voltage here, once I bring this 8 microcoulomb, the energy associated with that charge at this point in space is the charge times V. So the energy U is the charge times the voltage at that point. That's exactly what it means. And here the equation of the potential is K times the charge source of the potential over the distance. Alright? So now that's it. So considering 8 and 4, this is the energy associated with the system. Now, second, I'm going to consider the charge 4 micro and 8 micro and find what is the voltage, the net volt at point C. Due to these 2 charges, I'm going to ignore these. Okay, so that is 2. VC, the voltage here because of the 8 and 4 micro, would be constant, the charge over the distance, plus the contribution of these, constant, the charge for over the distance, 5 centimeters. And I find 25 times 10 to the 5th power volt. This is the voltage at point C, I call it VC, due to charge at B and A. Now, if you know the voltage, the energy associated with that charge at that point would be QV. And so this is the voltage, and the charge is minus micro. So you see the energy is the charge times the voltage. I find minus 12.6 joules. What is next? So I did this earlier. Now I'm going to do together. What about D? So I'm going to do the same thing. I need the contribution, the voltage of 4, the voltage of 8 micro, and minus 5 here. I can evaluate this distance. Obviously, it's 5 also centimeter. That's not really a problem. This is 5 centimeters. So let's evaluate the voltage at point D due to these 3 charges. So I have the constant 10 to the 9 power. I'm going to factor out this constant. I have also micro everywhere, so I'm going to factor out micro. And I have centimeters for the distance. I'm going to factor out centimeter, which is 10 negative 2. Okay, now I'm left with this charge to this, or let's say start from 4. Divided by the distance here is 4 centimeters. At 4 centimeters, I factor out the 10 negative. And then the contribution of 8, so plus 8. The distance is 5. And then here minus 5. I have factored the micro, and the distance is 3 centimeters. This is also 3 centimeters. Alright, 3, and I have factored out the 3. Now all done, you are going to find VD 8.4 10 to the 5th power volt, of course. Let's put this in circle. Alright, there's something wrong here. Oops. So that's the voltage at point D. Let's put this stuff here. I don't have to do it, but just to show the steps. Alright. Now, if you know the voltage at point D due to other charge, the voltage, the energy UD would be the charge at that point, which is 2 micro and 6 times the voltage at that point that we have just calculated, 8.4 10 to the 5th power. And I find 1.68 joules, because of the negative charge, of course, less energy. So now what's next? Did we answer the question? Yeah, no, not yet. So let's do this one here. So either energy or work, same. So I'm going to add, let's put color here. The energies are UB, that means this one. I have UC, and I have UD. No, not this one. Oh, alright, so I'm going to remove. Alright, not this one. This is the energy. I can circle energy again. So I'm going to add these 3 energies. Alright, so let's use. So the energy, total energy, which is also the work, because we agree on that. The energy stored is the work required to put them together. So that is 9.6 minus 12.6 and plus 1.68, and that is equal to minus 1.32 just 3 joules. Alright, so we are going to say this is the energy stored in this configuration, or the work required to bring these 4 charges together and put them in this configuration space. I hope these steps will help you reason. So now you can expand this reasoning to 5, 6, 7 charge as you please. Okay. All right.